This is the review guide for Chapter 4. The test is going to be tomorrow, Wednesday, December 11th, so make sure you're ready for it. The test looks very similar to this, so if you can solve all these without help, then you'd be in great shape for the exam. So here we go. First question is, hey, tell whether the function shown is a linear or a non-linear function. A linear just means it graphs to a straight line. So relatively easy. We should know right away that this thing's going to graph to a straight line. We can put it into form y equals negative 3x plus 10, which is the slope-intercept form for a line. The other way you can tell also, though, is that each x value maps to only, or is to the first power, and so is each y value. So it's 3x to the first power plus a y to the first power equals 10. And as long as you're to the first power with your variables, we don't usually show it, then you are going to be a linear equation. Number 2, so this would be yes, linear. Number 2 here, obviously it does not graph to a straight line. This is an absolute value function, in fact, so this is non-linear. And that's it for 1 and 2. Problem 3, remember your quadrants. This is quadrant 1, 2, 3, and 4, or if you prefer, you can 1, 2, 3, 4 rather than use Roman numerals. They mean the same thing. Graph a point in quadrant 4. That means we are going to graph a point somewhere down here, because this is quadrant 4. You can pick any point, it looks like. So I'm going to pick something easy. I'm going to run way over here. And I'm going to graph the point 9, negative 1. And I'm done. Number 4, slope equation. We've looked at a lot of these with graphs. Remember, we can make a little triangle from one point we know to another point. Then we just want to label these things or record these things in terms of a rise and a run. I would always do rise first. So this one rose by 1. So it's rise. Or there's its delta y, change in y. And then this is the run. Both of these are positive, because it's up is positive and right is positive. This is our change in x. I did it by 2. So it runs 2, it rises 1. Just make sure then when you write your slope, remember slope is rise over run, or it's change in the y, change in the x, which would be up 1 and over 2. So there's our slope. The points represent by the table line on a line. So these things are both lines. These are just some of the points on them. It says find the slope. All right, remember slope again, rise over run, or slope is how much does your y change per change in x. So let's figure these things out. See, my x went plus 3, plus 3, plus 3. And my y, on the other hand, went plus 4, plus 4, and plus 4. So every time my y changes by 4, my x changes by 3. And therefore my slope is 4/3. You do the same for this next one. Let's see here. They want us to... something peculiar happens here. All the x's are 5. In fact, your change in x is 0. And your y's, it looks like it goes up by, 9, and up by, that goes down by, 10, and goes up by 8. So there's no real pattern in the y, but the curious thing is when you find slope, remember, it's change in y over change in x. But my change in x is 0, so I don't care what number is up here in the numerator. It's division by 0. Remember, we say the phrase, no, you cannot divide by 0. So this is my 0 down there in no, can't do that. and therefore my slope is undefined. Your calculator would just give you an error, or it'd say domain error. It just says, hey, x cannot be 0, essentially. Don't forget, if we do have an undefined slope, this is a vertical line. And this vertical line always has an x value of 2, so there's where x is 2. And this is that line depicted in that table. And finally on this page, the first page, number 7, find the slope. And if they give you 2 points, and they say find slope, we better right away run to this equation. Okay, our slope equation. Remember I said for consistency, just always name the first 2 points, the first points, or the first point, x1, y1, and then x1, x2, y2. And then the process becomes easy. Take the 1, y2, subtract the negative 7, y1, and you take your x2, which is 6, and you subtract your x1, which is 2. Again, be careful when you have a minus and minus. That's the opposite of a negative, so this is just a plus. This is 8 over 4, so it looks like a slope of 2. So that's page 1. Should be easy. Practice those. Make sure you can do them. Page 2. Identify the slope. So normally we'd go to y, or m equals y2 minus y1, etc., except they've given us equations. And if they give you the equation of a line and you have it in slope-intercept form, y equals mx plus b, we can see the parts just lined up here. So y matches with y, x with x. The m is this negative thing right here, and the x matches with x, and plus and plus, and then the b lines up with 2. So as you're trying to figure out what your slope is, you're looking for the thing that is substituted in for m right here, and it's a negative. Well, we can't just put a negative for slope. They just haven't shown the 1 there, so our slope in this case is negative 1. Do not put the x value in there. Number 9, we do the same thing with, however, it is not in the correct form. We talked about these yesterday or on Monday. We said these were all pretty much 2-step problems. Move the x term over to the other side, either with addition or subtraction, whatever's called for. Make sure you put that negative 6x, the x term, right next to the equal sign. And then plus 12. So there's our right side, that negative 6x and the 12. So there's step 1. Step 2, get rid of the coefficient of y. Negative 3x plus 6. And again, we're just comparing parts with this. And we can see the m has to be negative 3. Equation of the line with the following characteristics. It doesn't say what form we have to be in, so we're going to leave it in the simplest form we can. In this case, they tell us m for a slope, and they tell us a point. Remember, we always need 2 things, point and a slope. In this case, though, this is a special point because they told us it's the y-intercept. And therefore, we're going to put this thing in slope-intercept form. Just substitution. Y equals my m, which is a half, plus my b, my y-intercept, which is 4. And that's it. You just write the equation. Number 11, not quite as easy. They gave us a slope, which is great. We don't have to go find it. They gave us a point, but unfortunately, this is not a y-intercept. Remember, y-intercepts have to have a 0 right there. If it had been 0, 8, that's a y-intercept, but it's not that. So if they just give us a general point, we use the general point-slope equation. Again, it's just a substitution problem. The only thing that I substitute in for is the y1, the x1, and the slope. The y and the x themselves are just going to stay inside the equation. So y minus y1. So that should be a y1 right there, sorry. That's 8 equals my slope. And then x minus, be careful here, x1 is negative 2. Now don't leave your answer like that. That's just laziness if you stop there. Go ahead, y minus 8, negative 3 fifths, x plus 2. It didn't say put it in slope-intercept form, so we're going to stop right there. Number 12. Again, remember, you need slope and you need a point. Well, we've got points. I don't care which one you use. I'm going to put the point negative 3, 2. You can use 3, negative 7. That would be just fine. They don't tell us slope, so let's go calculate our slope. Just using that slope equation, we used it on the front side. Negative 7 minus 2 over 3 minus negative 3. Remember, x1, y1, x2, y2. Let's see, negative 9 on top. Double negative is going to make it a 6 on the bottom. Now, top and bottom are both divisible by 3, so our slope comes out to negative 3 halves. Once we do that, we've got our point and slope. It is just like the previous problem. We do y minus our y value, 2, equals our slope, negative 3 halves, times x, minus our x value, again double negative right there, and we're going to clean it up because we are not going to be lazy. We are going to make it look nice. There we go. Again, it didn't say what form to leave it in, so I'm leaving it in slope or point slope form because it's just simpler, less chance for a mistake. 13 now. Again, I'm writing the equation of a line. So I need a point, I need a slope. I got the point I want to go through. It says right here, passes through, negative 3, 5. I have to figure out my slope. Well, with only one point, I can't find my slope. But it does tell me I'm parallel to this line. This line is in y equals mx plus b form. It has a slope of negative 2. If I'm going to be parallel to this line, I have to have the same slope. Therefore, I have to build a line with that same slope of negative 2 that goes through this point. I'm going to run to that point slope form, y minus 5 equals m x, and then minus negative 3, so it's going to be plus 3. So there's a double negative. I just didn't show it because we should start to get good at that. Stop there. Next one, problem 14, same idea. I need slope, I need a point. They gave me the point that I passed through. I have negative 9. They didn't tell me the slope. They kind of hid it here. They said I'm perpendicular to this line. Now this line has a slope of 1/3. The slope of a line perpendicular to it has a slope of, we have to flip it over the reciprocal, and we have to change its sign. In this case, it was positive, so now it's negative. Now, what I would do for this guy is just simplify this to a negative 3. It's much easier to work with that. You can use negative 3 over 1, they're the same thing. Lastly, now I just write my equation, point slope form. Y minus my y value, which is negative, so it'll be a plus 9. My slope of a perpendicular line for this situation, and there's my equation. Lastly on this page, page 2, find the x and y intercepts. X and y intercepts, remember, if you think about a graph, x-intercepts are where it crosses the x-axis. Y-intercepts are where it crosses the y-axis. So I'm looking for these 2 points. And when you find this point, for example, the x-intercept, it has some x value, but the y value is 0. That's why it's on the x-axis. The y-intercept, on the other hand, has an x value of 0 and some y value. The key thing is, if I want an x-intercept, all I have to do is make y 0, because that's what y is when I have an x-intercept. 6 times 0 is 0, so my x-intercept, negative divided by negative is positive, is going to be at, when x is 12 and y is 0. My y-intercept, though, I let x equal 0. So I have negative 2 times 0 plus 6y equals negative 24. 2 times 0, or negative 2 times 0, disappears. And y equals negative 4. Therefore, when x is 0, y is negative 4. My x and y intercepts. Last, the graphing. Make sure you're in slope-intercept form. Find your slope. Find your y-intercept. Okay. Y-intercept is on the y-axis. Then it says to go down by 2, 1, 2, and then go over 7, 1, 2, 3, 4, 5, 6, 7. So there's my other point right there. It looks like that's 7, 1. So we'll put our other point right there, 7, 1. 2 points define a line, so we'll draw in our line the best we can. Guess I should have put these down here. 17, not in slope-intercept form. So I slowly do the 2 steps to get me there. Move the x term. Left-hand side, these knock each other out, so I'm left with a negative 5y equals negative 2x on the left, this guy, and then that 10. And then divide away the negative 5. And here we go, y equals negative over negative is positive. Positive over negative, negative, so my slope is the 2/5. Y-intercept negative 2, mark your negative 2. We're going to count up 1, 2 over 1, 2, 3, 4, 5. So it looks like we'll be at 5, 0. We'll put a point there. And we'll draw our line. 18, there's a couple ways to do it, but we're going to do it the way that I think is easiest, which is put it in slope form, slope-intercept form. 2 steps, we've said. Distribute. 3 times 4 is 12. That was step 1. Step 2, get the y alone. That's what I get. 3x plus 14, slope of 3. Oops. It says point. So let's label our y-intercept as a point. 0, 14. 0, 14 looks like it's going to come off of this. It's going to be up here. Way up there. Slope is 3, so I'm going to come down 1, 2, 3 over 1. 1, 2, 3 over 1. And so my line's looking something like that. They're trying to force you, obviously that's kind of tough to graph, to actually do it this way. Slope is 3, we can tell that. And if we compare the equation they give us to our point slope equation, right there, sorry. X2 right there. So we're just comparing it to our point slope form, or X1, I guess. If we were to compare the equation they gave us to our point slope form, we can start to tell a point that it goes through. We can see y is y, negative is negative, but we can tell right here, therefore, that y1 had to be a 2. So that must have been the y value of the point that it goes through. Again, comparing parts. M is the 3, I already knew that. My parenthesis, x's line up. My plus sign, though, does not line up with my minus sign. Okay, and so that means this must be a minus -4. Because if I think of this as a minus, now my minuses line up, and my x1 is a -4. So if I use this point, -4, 2, and by the way, I goofed up my points. I'm going to show those again. But let's graph -4, 2, which should be right there. My slope should have gone up 3 over 1, 3 over 1, up 3 over 1, and then up 3 over 1, which was that point way up there. Either way I do it, I'm going to get the same equation. I still would put it in slope-intercept form, and then try and graph that if it fits. Now, if it doesn't fit very well, like in this case it didn't fit very well, I think I would still put it in slope-intercept form, like I showed you above. I'd pick a number for x that gives me something reasonable, like I might choose -6 for x. And I just have to substitute that in. That's -18 plus 14, -4. And then I could come over to my graph and I could use that for my point. -6, -1, 2, 3, 4. So our graph is a little bit off. But all you have to do is find any point on the line and count your slope. Last one, this is just in what we call standard form. AX plus BY equals C. 2 ways to do it. I always like to have one way I always go to. The way I always go is just let's just put it in slope-intercept form. Divide by 6. 4 over 6 is 2/3, so 12, plus 2. Y-intercept is 2, up 2 over 1, 2, 3. So I mark my y-intercept, went up 2 over 3 for my slope, and that is my line. Because this is in standard form, though, they did want you to attack it this way. I said, well, let's just find our x and y intercepts. We'll let x equal 0, which makes this whole thing right here disappear. -4 times 0, and it just leaves you with 6y equals 12, or y equals 2. So when x is 0, y is 2, and that's this point that we found down here. And then you find the x-intercept by letting y equal 0. So when we let y equal 0, this whole term disappears, and you have -4x left equals 12. And divide by -4. So at -3, we're at 0. -3, 1, 2, 3, 0 is right there. So there's the exact same line, but there's doing it with x and y intercepts. So you can always go to slope-intercept form, or you can find a couple of points and graph your line. That's everything on the test. You can do all these things, you should do great. And not just do them, you want to be able to do them quickly, efficiently, and correctly.